Now we have something called quota problems. Quota problem is basically you're trying to meet a quota. And what this means in terms of the binomial distribution, it means basically we want to know N here. We want to know how many trials we need to be able to ensure we have so many successes, at least this many successes. So let's take a look at this example here. Junk bonds can be profitable as well as risky. Why are investors willing to consider junk bonds? Well, suppose you can buy junk bonds at a tremendous discount. You try to choose good companies with a good product. The companies should have done well, but for some reason did not. Suppose you consider only companies with a 35% estimated risk of default, and your financial investment goal requires 4 bonds to be good bonds, in the sense that they will not default before a certain date. Junk bonds that do not default are usually very profitable because they carry a very high rate of return. The other bonds in your investment group can default or not without harming your investment plans. Suppose you want to be 95% certain of meeting your goal, which is the quota of at least 4 good bonds. How many junk bonds issues should you buy to meet this goal? Okay, so for this particular problem here, a success is a junk bond that turns out to be a good bond. Or more concretely, the single junk bond actually doesn't default. All right, so X equals basically 0, 1, 2, all the way up to N. N is what we're looking for. We want to know how many bonds to buy. So we want to know how many junk bonds to purchase to meet our quota. Little p here is 0.65 because since 35% is the estimated risk or default. Okay. In other words, you just went 100 minus 35% to get 65%. Okay, so what do we need to do to meet our quota? So to meet our quota, we need to satisfy P X is greater than or equal to 4, greater than or equal to 0.95. So we need to satisfy that the probability that we get at least 4 junk bonds that don't default, we want that probability to be greater than 0.95. That's the confidence part. We want to be 95% confident to meet our quota. So 95%, we want at least 4 junk bonds to be good bonds, so that to ensure that our confidence of this is more than 0.95. Okay, that's what we're trying to satisfy. Okay, so to do this, we basically need to ensure this gets bigger than 0.95. So what we'll do is vary in. We want to vary in. So if we go to our calculator, in our probability, well, first let's specify our probability of success. So that's 0.65 in this case. And we want to ensure that we have to buy at least 4 good bonds, junk bonds that are actually good, so junk bonds that don't default. So we have to at least purchase 4. And we're going to take a look at this value here because that's the probability X is greater or equal to our value of 4 here. Okay, so we want to make sure we plug 4 here because we need to purchase at least 4 junk bonds. And this probability is what we're going to pay close attention to because we want that to exceed our confidence. In other words, we want to be 95% confident that this number is greater than or equal to 95%. All right, so we're going to vary in. We're not going to vary the value R because we only care that we get at least 4 good bonds or junk bonds that are actually good bonds. So we're going to vary in here. So if I see this, I get 5. You can see now that the probability is now about 43%. Now let's see if I go to 6, we could see that number now getting bigger. Now it's around 65%. 7, okay, now we're pretty close to 80%. 9 or 8, excuse me. You can see it's now 89%. And 9 is now 94%. Now, technically, this would round to 95%. However, this is money, so we want to make sure it exceeds it. And so, plugging in 10 there, we got 0.97%, and that will satisfy our quota. Okay, so n equal to 10 is how many bonds we need to pick. So, is the minimum number of junk bonds to purchase to meet our quota.